Alright, so today we're going to be talking about triangle similarity and the different ways to show that two triangles are similar. So this is kind of like when we talk about congruence, except this time it's similarity. So you'll notice that we before used to have side, side, side. Well, in this case it's side, 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 similarity. This symbol means similarity or similar. So we have side, angle, side, 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 and angle, angle. And all of these are similarities. So you notice that we have the little squiggle at the end of them. Alright, so we have some vocabulary terms. Angle, angle, similarity. If two angles of one triangle are equal to two angles of the other triangle, then these two triangles are what we call similar. Alright, and we also have side, side, side similarity. So, if the sides are proportional, let's say 2, 4, and 10, and then we're going to multiply this by a scale factor of, let's say, 3, so 6, 12, and 30. So these two triangles would be similar because it has a scale factor of 3. So side, 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 similarity. And then side, angle, side has, let's say this is 8, let's do this. Let's say this is 4, and this is 3, and we want to dilate it by a scale factor of 2, so it'd be 8 and 6. And let's say that this angle is 40 degrees, and this angle is 40 degrees. So by the side, angle, side similarity, these two triangles would be similar. Now let's say that we have another set of triangles, so I'm going to copy these. Alright, so let's say this time we have 4 and 3 and 40 degrees here, with 8 and 6 still in the same place but 40 degrees here. These would be not similar. The reason for that is that the angle is not in between the two sides. Remember that it has to be an included angle. So just the way that side, angle, side works for congruences, it works for similarity. The angle must be included, meaning between the two sides. Alright, so using the angle, angle similarity, we can work a couple of problems. Now looking up here, I notice that I have a right angle, and I have 38 degrees and 52 degrees. Now, I don't know if these are similar yet because 38 and 52 are not the same. However, the triangle angles must add to 180. So if I do 180 minus the 52 minus 90, I'm left with 38 degrees. So by angle, angle similarity, these two triangles must be similar. Okay? And this one would also be 52 if you follow the directions down below. Alright, so let's go ahead and take a look at this right here. What I have here is an isosceles triangle where this is 115. So I know that the base angles must be congruent of an isosceles triangle. So 180 minus 115 leaves me with 65 degrees. I divide 65 by 2, and I know that these two angles are 32.5 degrees. Right here and right here. Alright, now if I do the same thing, I've got 115. These two angles must be the same. So 180 minus 115 gives me 65, and then I divide it by 2 to find the two missing angles. So these two triangles are in fact similar by the angle, angle similarity. Okay? Over here we have two parallel lines. I notice that both the big triangle and the little triangle share angle N. And I know that if these are parallel, then this angle and this angle must be congruent by corresponding angles. So the two triangles are similar by the angle, angle similarity. Alright, so right here I want you to try these 4 problems. Basically, as of right now, you have two options. They're not similar, or that it's angle, angle similarity. I want you to pause and try the problems now. Alright, so you should have your problems completed. If not, you should not have unpaused your video. Alright, so what I have here, these two angles are congruent by the vertical angle theorem. So that means the two triangles are congruent by angle-angle similarity because I have two pairs of angles congruent. Over here, I want to find the measure of this angle, so I do 180 minus 71 minus the 90-degree angle, and I'm left with 19 degrees. So by the angle-angle similarity, so I have this angle here and here, this angle here and here. So by angle-angle similarity, these two must be congruent. Right here, I'm going to do some quick math, and I have 180 minus 28 minus 72. So what I have here is 80 degrees. As of right now, all I have is one pair of congruent angles, so I don't have enough information. I would just basically say these are not similar. Because if I were to find this other angle over here, it would be 70 degrees. And you'll notice that these are not the same, so they can't be the same. Can't be similar. Alright, now with this, I know I have vertical angles congruent. And I also know these lines are parallel, so I can say the alternate interior angle theorem that these two angles are congruent. So by angle-angle similarity, with the use of the alternate interior angle theorem and the vertical angle theorem, these two triangles must be similar. Alright, so using side, 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 okay? We need to determine if the first triangle is similar to either the second or the third. Okay, so looking at this, I have 10, 10, and 12. To go from 10 to 8, we need to find the scale factor. So to multiply 10 by 4/5 would give me 8. Okay, now we have to be careful because sometimes we could also have rotated it, but if you look and I multiply 12 by 4/5, I will not get 6. So that means this is not similar. Alright, so now I'm going to erase these. Alright, I have 10, 10, and 12. If I multiply 10 by 1/2, I get 5. 10 by 1/2 is 5. 12 times 1/2 is 6. So these are similar by the side, side, side similarity. And your scale factor here is 1/2. Alright, now here we have 8, 9, and 10. If I multiply 8 by 1/2, I get 4. 9 by 1/2, I get 4.5. And 10 by 1/2, I get 5. So these two are similar by the side, side, side similarity because they're all proportional by the scale factor of 1/2. Alright? So then you take a look at the next one, and the next one you are not similar at all, okay? There is no scale factor that I can use to multiply or dilate the first ABC onto SRT. Alright, so using side, angle, side, let's go ahead and determine the angle measures. So, let's see. Scale factor. So we want to find the scale factor and determine if they are similar. So I have side 3 and side 12. So I'd multiply 3 by 12 to get 4. So that's probably my scale factor. So let's go ahead and put that. I can confirm that because 4 times 4 is 16. So my sides are proportional. Alright, and then do I have the angle in between them, and are they the same? And they are. So this would be what we call the side angle side similarity postulate. These two triangles are similar by SAS similarity. Over here, I would need to find the scale factor. So 9 times what will give me 16? So 9 times what gives me 16? X equals 16 over 9. So that should be my scale factor. So if I multiply 10 by 16 over 9, oh, I do not get 18, do I? I get like 17.8. So it's close, but it's not the same. They're not proportional, so this would be not similar. Alright, so remember that when we talked about triangle congruence, it was very important about how we named things. And the same applies for similarity. Okay, so if I were to look here, GH and PQ, so GH and PQ, those are the corresponding sides. Now they're not congruent, however they are similar. So HJ is similar to QR, and GJ is similar to PR. Now, we know that angle G and angle P are corresponding angles. We also know they are actually congruent. Remember that dilation preserves angle measure? So if I have a similar figure, the angle measures should be the same. Okay, so only the angles are congruent, but the sides are similar. Okay? Go ahead and pause and try number 2. Alright, so take a minute and check your answers. Alright, so let's go ahead and see if we can explain if these triangles are similar, and if they are, we have to state why. So like before, in the congruences, I didn't allow you to just say yes, you had to say why. So I noticed that I have these two angles 100 degrees, and also by the vertical angle theorem, these two angles are congruent. So the two triangles have to be similar by angle-angle similarity. Now it's our job to also write the similarity statement. So I would say that triangle ABC is similar to triangle, okay, well A and E correspond, B corresponds to D, and then C. So that would be your similarity statement. It's very important to name it correctly. Alright, this is an equilateral triangle, okay, which means all the angles have to be 60 degrees. This is an equilateral triangle, which means all of the angles must also be 60 degrees. So the two triangles are similar by the angle-angle similarity. Alright, so our triangle congruence here should be that TUV is similar to triangle YXW. Alright, in our next video we will be applying these properties of similar triangles. So I will see you then.